All right, this is our last boards go up, please, of the year. So I am gonna have you do problem number one. Um, it is, I haven't given you one of these before, but I really like them. Um, and uh, there's a lot of critical points, but it's nice in that you do get a lot of triangular matrices. So, hold on. There are a total of 8 critical points. I'm going to help you find them, and then I'm going to let you go. And then actually, maybe I'll help you with the partials. Um, uh, this guy right here, 0 with 0, you should see that, and then 0 with -5, right? And then I pair what would make this 0? Well, 1 with what? 0. 1 with what? -5. What goes here? Oh, it's -1 with 0, -1 with 5, and then 3 with 0, and 3 with 5. You may say, hey, Larry, you never talked about this guy here. Well, that's because if I make x a value with the top line to make it 0, then I can't go and make that x value 2. So you should see that. So I do have 8 critical points. I made this so that it was easy to multiply. If you look here, I got x minus 1 and x plus 1. That's difference of two squares. You can do that. And then you can multiply by the x minus 3 because it's really only 2 terms, so it's like foiling. And then you can raise everything by a power with this x, right? And then this should be pretty quick to multiply too. So I would multiply all those out and then find your Jacobian matrix by taking the derivative of that thing. So you could try that. I will scroll down in a moment so you can check your Jacobian matrix before you get too deep into the actual phase plot. So go ahead, find your Jacobian. See if you got all your critical points listed out. I'm going to scroll down. So you should get this for your x prime once you FOIL it out, this for your y prime once you FOIL it out, and then your Jacobian is this guy right here, right? Notice we have a 0 there, so everything's going to be triangular. So your eigenvalues and eigenvectors are all going to be the entries along here. And then you've got these guys. Fortunately, there's lots of zeros here, right? The ones that are going to be the most complicated to plug into all this stuff are going to be the 1, 5, -1, 5, the 3, 5, right? All the other ones have zeros, so that's convenient. All right, here come your individual little phase plot pieces or your critical points. 0, 0, you get that. It's just a saddle. Sink, sink, source. You should see those. And you should see all those eigenvalues or eigenvectors that go along with them. I'm going to let you finish the rest of them. So that's those first 4. Should make sure that you have the rest of them before you should pause and do that, and then I'll scroll down in a moment. Okay, here it comes. We get these guys. Fortunately, there we get zeros, and look, there's a 0 there again. 0, 0, right? So I think the most work is plugging the 3 and the -5 in to that Jacobian matrix and getting these. Then after that, it's it's triangular either way, right? But it's triangular, so and then you put it all together and you get this wild thing like this, right? So I wanted to do this one because this is something that I have done in this class for a long time. Wait, you should see. Where is 0, 0? Ooh. So that's 0, 0 right there, I think, right? The 3, -5, all the -5s are down here, right? So those are those y values, -5. Yeah. Anyway, this is one that I've done for a long time, and I wanted you guys to at least see it. Normally, we would spend a bunch of time practicing these, but yeah, now you can just see it. So, all right, I will do the next one as its own video.